Ever pondered why the geometry of molecules is not always what we predict using the valence shell electron pair repulsion theory, or VSEPR for short? Well, there's a simple yet profound rule in the world of chemistry that helps solve this mystery. It's called Bent's rule. Henry Bent, an American chemist, proposed this rule, which explains the relationship between the orbital hybridizations of central atoms in molecules and the electronegativities of substituents. The rule states, atomic S character concentrates in orbitals directed toward electropositive substituents. So, what does this mean? Let's break it down. Orbital hybridization is a concept that provides a detailed quantum mechanical model for explaining the behavior of electrons in atoms. It is a mixing of atomic orbitals to form new hybrid orbitals suitable for the pairing of electrons. These hybrid orbitals are directed towards regions of high electron density, meaning they are drawn towards more electropositive elements. The atomic S character refers to the properties of the S orbital, one of the shapes of the atomic orbitals. This S orbital is spherical and is closer to the nucleus than the other orbitals, like the P, D, and F orbitals. Hence, as the S character in a hybrid orbital increases, so does its electronegativity, the ability of an atom to attract shared electrons to itself. Now let's apply Bent's rule to a real-life example. Consider the molecule Me2XCl2, where X can be any of the main group elements like carbon, silicon, germanium, tin, or lead. The bond angle between chlorine X chlorine is smaller than the carbon X carbon bond angle. This is because with the highly electronegative halogen substituent, chlorine, more P character is concentrated on the central atom in XCl than XC bonds. Bent's rule helps us understand and predict this. So, in essence, Bent's rule allows us to predict molecular geometry by understanding that atomic S character will concentrate in orbitals directed towards more electropositive elements. It's a rule that elegantly combines aspects of molecular geometry, electronegativity, and orbital hybridization. To recap, Bent's rule states that atomic S character concentrates in orbitals directed towards electropositive elements. It explains the relationship between the orbital hybridizations of central atoms and molecules and the electronegativities of substituents. It also helps us understand why the S orbital, being closer to the nucleus, has a higher electronegativity. And finally, it allows us to predict molecular geometry by understanding how the atomic S character and P character distribute themselves in a molecule. So, the next time you find yourself puzzled by the shape of a molecule, remember Bent's rule. It might just have the answer you're looking for. After all, in the world of chemistry, understanding the rules is the first step to solving the puzzle.